Alright, here we go. First day of Unit 2. First thing we're doing is we are solving rational equations. Now we just finished rational equations. We did undefined, we simplified them, we multiplied, divided them, and then we were adding and subtracting with them. So what we're doing now is actually taking it and making it an equation. So we've got our equal signs before, whereas before they were expressions, so there weren't any equal signs. Now there's two kinds of problems you'll have to deal with. One of them is if they are proportions. If they're proportions, you're going to have a fraction equal to a fraction. And that's how you know it's a proportion. So you've got one fraction on each side of your equal sign. So when you have a proportion, all you need to do is cross multiply and then solve for your variable. And then the second step here says to check for extraneous roots. And so we'll go through that in our examples. Example 1 here. So we have one fraction equals one fraction. So we need to cross multiply. So I'm going to do x minus 3 times 2x plus 3. And that's going to equal x minus 1 times x plus 3. When we cross multiply, they then become equal. So we're going to do our distributing. I got to do x times both of those, negative 3 times both of those. So I get 2x squared plus 3x minus 6x minus 9 equals, and the same thing over here. I got to do my double distributive. So I get x squared plus 3x and negative 1x minus 3. Now keep in mind, guys, since this is a video, if any point in time I'm going too fast, you can just pause it and take time to write down what's going on so that you can also listen to what I'm saying. So at this point, we want to combine our like terms. So on both sides, we have some x's to combine. Equal negative x squared plus 2x minus 3. So now, since we have some x squares in here, we want to get those together. So I'm going to subtract x squared over to this side. In the same step, I'm just going to bring everything over to this left side. So I'm also going to subtract my 2x, and I'll add my 3. So that makes these cancel. So this is equal to a 0 now. Over here on the left side, I get x squared minus 5x minus 6. So at this point, since there's an x squared term, in your head you should be thinking, oh, I need to factor. Factor's our favorite thing right now. So I'm going to factor these out. This is going to factor into x minus 6 times x plus 1. So when I set them equal to 0, I get x equals 6 and x equals negative 1. So I'm not going to say that those are my answers yet, because what I have to do is I have to go back and check to see if either of those answers gives me an undefined fraction back at the beginning. So if I go up to the beginning here and I plug in a 6, I'd get a 5 for this denominator, which is fine. If I plugged in a 6 over here, I'd get a 15. So 6 works. It's not an extraneous answer. So now I need to test the negative 1. So if I plug in negative 1, I'd get a negative 2 in my first denominator. If I plug in a negative 1, I would get a 1 in the other denominator. So again, the negative 1 also works. So I get to keep both answers this time. Over in example number 2, what we have to keep in mind is that second fraction is over a 1. We don't always write it, but it is definitely there. So we're going to cross multiply, so I get 14 times 1 is equal to negative 2 times a minus 3. So then on my left side I get 14. Right side I get negative 2a plus 6 when I distribute my negative 2. So then I subtract 6 from both sides, and I get a equals negative 2a. Divide by negative 2, and I get negative 4 equals a. So if I go back to the beginning, I only had the one fraction. I have a 1 over here on the right side, which I don't need to test to see if negative 4 makes that undefined. It's not going to. I just need to check over here in the first fraction, and that's going to give me a negative 7, so that works. So a equals negative 4 is our answer for that one. So again, fraction equaling a fraction, cross multiply. I feel like you guys already knew that. It's when it's not a proportion that we have a little bit more work to do. We have to go back and find our LCD, which remember stands for our lowest common denominator. So we were using this when we were doing our adding and subtracting of our fractions. We found our lowest common denominator then. So if we look at our first example, we have 1/6 plus 1/12 equals 1 over m squared. And again, this is an equal, so this makes it an equation. And then this stuff afterwards, that's just telling you that your fraction at the end there is not undefined. Because if m equals 0, we would have a 1 over 0, which we can't have 1 over 0. So this is simply saying you cannot get an answer of 0. If you did, then your answer is not correct. So what I need to do here is I need to find a common denominator. So looking at my numbers, I can make a 6 turn into a 12. So number-wise, we're going to have a 12. But there is this m squared here, so that also needs to be part of our common denominator. So 12m squared will be our new denominator. So then I have to go back. Okay, I can turn 6 into a 12 by multiplying it by 2, but it also needs that m squared. So I multiply my first fraction times 2m squared. And then if I look at my second one, it's already got the 12, it's just missing the m squared. So I need to multiply times m squared for that one. So that gives me m squared over 12m squared. And then our last one here, it's got the m squared, it's just missing the 12, so I need to multiply times 12. So that gives me 12 over 12m squared. So now all of my fractions have the same common denominator. So when that happens, you can then cross out the denominator and just solve the numerators like they are a regular equation. So 2m squared plus m squared equals 12. So I'm going to add my like terms. I'm going to divide by 3. So m squared equals 4. So at this point, to undo a squared, you have to take the square root. But what you have to remember is that gives us two answers. It gives us plus or minus 2. Reason being, if I took a positive 2 and I squared it, that would give me 4. Because remember, that means that it's 2 times 2, which is 4. Same thing happens with a negative 2. If I square negative 2, that means it's negative 2 times negative 2, which is also a positive 4. So since I put that square root sign in there, I had to have both answers of plus or minus 4. A lot of times you'll already have a radical in the problem, so you don't need to add the plus or minus in that case. It's when you introduce it that you need to make sure you have the plus or minus there. So now the plus or minus 2 is my answer because remember, I only couldn't have a 0. That's not 0, so that works. So that problem is done. Looking at number 2 now. I'm going to put my 4 over 1, so now I have my 3 fractions. Again, we need our common denominator. So my common denominator this time is going to be a 2a. And that last fraction there, our third fraction, is already over a 2a, so I don't need to change that one. Again, I cannot have an answer of 0, because a 0 would make our fraction undefined. We don't want that. So our first fraction, we need to multiply top and bottom times 2 to get to our common denominator of 2a, keeping our fraction equivalent. The second fraction, I need to multiply times 2a. So that gives me an 8a over 2a. So now we have all same common denominator. Cross it out. Now we have a normal, regular equation that you guys are really good at solving. So I would subtract my 4. I get a 0 equals 8a. Divide by 8. 0 divided by 8 gives me a 0. But as we remember, we were told back at the beginning that a cannot equal 0. So since we got that, that means there's actually no solution to this, because we were already told a can't be 0, so therefore we have no answer for problem number 2. And then our last one in this page of notes here, we have x plus 4 over x plus 3 over x minus 4 equals negative 16 over x squared minus 4x. So if you factor the GCF factor in that second fraction's denominator, you have x times x minus 4. So if you think back to what we did last time, this would end up being our common denominator. This one already has the x minus 4. That fraction already has the x. So we just need to multiply them together to give us the x times x minus 4. So again, that third fraction has already got the denominator, so we're going to leave it. Second fraction, I have to multiply times x. So that gives me a 3x in the numerator. First fraction, I have to multiply times x minus 4 to get me my common denominator of x times x minus 4. So that gives me x squared minus 16 in my numerator. So now, all have common denominators, cross it out. X squared minus 16 plus 3x equals negative 16. So we got to get everything on the same side. I'm going to add 16 over. But what ends up happening is it gets canceled on both sides, which is okay. So we're left with x squared plus 3x equals 0. And we can still factor that. That's a GCF factor. So it's x times x plus 3 equals 0. So we have to set them equal to 0. So here x equals 0. And then here x equals negative 3. So if we look back, we were told at the beginning x cannot equal 0. So that's actually not an answer. We're going to call this extraneous, which is why it gets rejected, because it's not actually a number. It makes our fraction undefined. So then x minus 3 is our only answer there.